And hello everyone and welcome back. This week we continue our conversation about texturing inside of Modo by talking about the nodal schematic system inside of our shading environment. Now as you can see, I'm working with the class09_start Luxology project file, and once again I like using these grand ideas, taking these very complex ideas and trying to distill them down into something that's relatively small, something that's manageable. So I stepped away from my treasure chest scene here for a moment, and I want to focus on just this simple little goblet scene. It'll allow us, I think, to more easily see the impact of these ideas inside of our little project. And let me just take you on a quick little tour of what I have here. If you look, just a cool little goblet. You've seen this before. And over inside of our shader tree, I have a simple little material group that has a whole series of gradients that are giving me the result that you see on the screen here. And everything is looking generally pretty good. I'm very happy with the results that I've gotten so far. However, if we zoom in, we can start to see a couple issues that are coming to the surface inside of the details of our render. And specifically, my brain is looking at how the computer is transitioning between these lovely little flutes down in here, okay, across this little radius. Now, this isn't exactly the result that we're after. And actually, excuse me, this is the default result that you should be getting. I accidentally had the rounded edge width value at 10 millimeters, and this isn't real. This is catching my eye, and it's causing a problem for me in the final render of my little environment, because the light is not pooling. The light is not reflecting and gathering in these transitions as they naturally should be. Now, geometrically, we could go in and add this detail in there, but of course, it would start to add some more geometric weight to my scene, and that's something that I want to that I need to kind of rein in and keep in the back of my mind, especially given the context of our larger treasure chest scene. We're going to have a bunch of stuff in there. How much information we're asking the computer to render is going to play a factor, especially in larger environments. So being able to add that illusion quickly through a shader inside of our shader environment is attractive to me. And specifically, check it out, I have the material selected, and this rounded edge width is the one that I want to work with. And let me just put this at a value of 10 millimeters. Yeah, and I'm already starting to like what we're getting here. You can see that the light is pooling differently. The specular highlight is deforming around this radius, and I'm getting something that looks a little bit more integrated. The first hallmark of something that's computer generated is the absence of these little radiuses in here, and this rounded edge width value in our material is allowing us to walk closer to that final result. However, it's very uniform in size, very uniform. This doesn't look exactly organic, and it doesn't look influenced by man because it's very even. Now, if this is something out in the real world, there'd be small little variations in this rounded edge width. There'll be certain areas that would be beat up. Certain areas that would be influenced by the environment. Shoot, maybe even the oils in our skin would go in and start to increase and decrease the quality of this radius. So I want to go in and continue to modulate this and add a new level of creative detail in this area that will help me achieve the result that I'm after. And this gives us a great opportunity to talk about how we can continue to work with this channel inside of the nodal shading environment. So let me just minimize my preview window down here. And as a reminder, I'm in the render tab, and of course down here at the bottom, we have a whole series of viewport tabs, and I'm just chilling in the schematic environment, okay? And the schematic environment will allow us to take all of these items inside of our shader tree and influence them non-linearly in a nodal environment. The shader tree works very hierarchically, very similar to the way that Photoshop works. The elements that are on top are often going to obscure and occlude all the elements below, just like Photoshop, okay? So the nodal shading environment allows us to kind of sidestep this entire shader network and work non-linearly, very similar to, let's say, like the Hypershade works over inside of Maya. Now, before we get started, it's important to note that we have to have something inside of our shader tree that's currently affecting the polygons inside of our three-dimensional scene. So I have a material group that has its own material. That is the bare minimum. We have to have something inside of our scene that's already shading our polygons for us to work with. And I want to start focusing in on this bad boy right here. To add this element into our schematic, there's two easy ways that we can do it. The first way is just to left-click and drag it into the schematic, which is pretty great. The other way is just to select it inside of the shader tree, and then over in the schematic viewport, check it out, we have a button right here called Add Selected, and it will do the exact same thing. Now, don't freak out. You're looking at this material probably saying, wow, is this it? Are these all the channels that I have access to? Nope. This isn't it. Actually, this is a very small representation of the total number of channels that we can nodally start to influence inside the schematic environment. These are just the defaults, the best of, the rock stars, if you will. We want to add in another one that's not currently on the list. We want to work with this rounded rounded edge width value that's inside of our properties tab. Again, two ways of getting it in. So I need to add it into this item that's sitting in our schematic. If we go into the channels tab, let's see, you have to scroll down here a little bit. There it is right there. We can simply left click and drag it into our schematic. It'll automatically be associated with that element inside of our environment, which is pretty neat. So now that we've exposed the channel that we want to work with, we want to add in a new element that's going to modulate that value across the entirety of our environment. Now I want to add a noise texture, and the cool thing about working inside the nodal shading system inside of Modo is it allows us to create elements that are universal, that can be used and influenced, or that can be influencing other items inside of our entire shader network. If we look at what we have going on here, this gradient right now is only influencing the polygons that are associated with the gold material group, and it's only ever going to influence these items in here. The nodal schematic environment allows us to create almost the exact same thing, but they can influence many different materials inside of our scene, and let me show you what I'm talking about. Of course, we always could go in and do add layer, texture, noise. That's a way of getting this noise texture into the mix, but let me show you another way. I want to go back into my schematic, go add, and then under shader nodes, texture, here are all the procedural textures that we find inside of Modo. Let's just go ahead and add one in. Now, let's talk about what is being, or where this element is currently being stored inside of our shader environment. It shows up in the schematic, but look over here in our material group. That noise texture does not show up here. This is the original noise that's influencing the diffuse color. It's not the new one. If we continue to go down our shader tree a little bit, check it out. We have a folder here called noise, or nodes, and there it is. There's that new noise texture. So anything that we create under this add pull-down menu is automatically going to go into this area. Now, that's not to say that we can't select this thing and left-click and drag it into our material group. We absolutely can do that. That's part of it. But notice that the effect is not automatically applied. We can also just put it back in there, which is what I want to do, because I want to use this element throughout a number of different materials inside of our scene. More of a universal element that can be connected to many different materials instead of one that will only be influencing this material right here. Okay, let me just give you a little tour. If you've never worked inside the schematic before, it's really, really easy. Of course, you can grab the header for each one of these and left-click and drag them around, and we can move the nodes wherever we want. All these little dots on the left and the right are little input and output nodes. So the flow of information starts on the left and it goes toward the right. These are all the inputs of each one of our nodes. These are all the, these are all the outputs over here. These little gold diamonds shows us that there's a relationship between this channel and another item inside of our scene. If we were to simply double click on the gold diamond, it's going to show us the related item, and in our case, it's just the texture locator. Now, whenever we have a relationship between two different items, Modo's going to draw this nice little wire between them. Of course, we can simply left click and drag on that wire to automatically retarget and disable its influence from the other nodes within inside of our scene. Now, what we want to do here is that we want to take all the noise information, specifically all the value information that this black and white texture is creating, and use that as an output to influence our rounded edge width value over there on the material, over here on this guy inside of our goblet. Let's simply make the connection between our noise texture and our material by left-clicking and dragging on the texture value output channel over here onto the rounded edge width. And there we go. Now, don't freak out. If you're starting to see some of these shading artifacts, don't worry. We have a couple extra steps in here that we need to do. Basically, what's going on here is that we're rounding out these values too much, because now we're taking the default output of this texture value and using it as an input, and it's just way, way too high. So we need to start fine-tuning this a little bit. We need to start reining this in and dialing in the values so that we can control it and ultimately get the result that we're after. Now, to do this, we're going to intercept the signal and add a new modifier into the mix so that we can change the value as it's going from the noise texture into our material. So let me select the wire. Notice that it's gone orange. And then under the Add Pull-Down menu, we'll do Channel Modifier, Math, and we're going to do Basic. Let's see, there it is, Multiply. And you can see that we're now intercepting the signal. Now check it out. We have a little multiplication signal, and it has two different inputs. We have the input that's coming from the texture value itself, and then an empty one down here. With it selected over in the Properties tab, you can see the value A and value B. Value A is grayed out because it's coming directly from the texture value output of our noise, and value B is set to 0, thus disabling the rounded edge value, because any value multiplied by 0 is always going to give you 0. However, if we start increasing this value B, we're going to start to see that rounded edge value show back up inside of our goblet. Let me just do it real fast. Yeah. Check it out now. We can start to see that rounded edge return. And if you look very, very carefully, there is some variation in that rounded edge, okay? We're basically multiplying the noise value that's coming from this texture, but it's not enough. And let me just overdrive it. I'm going to grab the texture locator with the noise, and I'm going to change its size to something really small. That way you guys can see precisely what's going on. Maybe even something like 10 millimeters. Yeah, now it's looking all squiggly, which is kind of cool. It's starting to look like that transition between this part of my goblet and this edge has been beat up and influenced quite a bit. All thanks to this nodal schematic system that we've created. We're intercepting the value, we're changing its number. Let's look at it up here. Yeah, pretty cool. Sometimes it's the small little details that go a long, long way. So this is just the beginning of the nodal schematic system inside of Modo. We're allowed to very quickly start changing the rules and intercepting things and adding new values into the mix. Look at all this lovely little detail up in here. Now, in the past, that would take some energy to create, but thanks to the nodal detail system, or excuse me, the nodal schematic system, we can create it pretty quickly here inside of Modo. Let's look at another example of how we can continue to use the schematic and nodal shading system inside of Modo to help us get the results that we're after. In this next section, I want to show you guys how we can very easily and very quickly use the schematic nodal shading system inside of Modo to help us create a more efficient shading network. And let me show you specifically what I'm talking about. Let me minimize this window. And of course, here's the shading network, the nodal network that we were working with before to give us our lovely rounded edge with detail. But now what I want to do is go in and start creating a very similar effect to what we explored last week when we were doing all the masking between the different groups. We set up one material, and then we set up a whole series of other materials, and we masked between them, especially around the corners, to give us this wonderfully weathered edge effect. And I want to show you an alternative way of setting this up using the schematic, and it's really, really quite simple. Like we did last week, let's go ahead and start initially creating a whole series of subsequent materials that we'll use to create the edge detail for my little goblet here. So here's the gold material group, which is responsible for shading the entirety of my little goblet here. And now I'm simply going to go in and start taking my existing system here and placing it in its own folder. So let's just go ahead and do that. And we'll call this folder brass. There we go. And we'll place all of these elements inside that folder. There we go. And now what we'll do, just to make it a little bit easy and very obvious to see what's going on, we'll create a new material, and we'll place it inside of my gold material group. We'll have to place it below the brass section. There we go. Lovely. So right now the brass is on top and is overriding this one. Wonderful. We'll turn it off just temporarily to see what the results of this material is going to be. And let's just make it kind of a silvery material. So we'll turn up the reflection amount quite a lot. Maybe make it like 80, kind of shiny along the edges on Fresnel. Of course, it's going to be blurry. The reflection color, let's make it kind of a silvery color, and we'll also dump down the diffuse. Yeah, so now I kind of have this really neat pewter effect going on in here, and I'm generally really liking the results that I'm getting. And the whole idea is that we have a group mask inside of this folder that will allow us to mask out the edge details between these two different materials. Now, in the previous lesson, we talked a lot about the masking system, and I want to show you an alternative. Let me just do it real fast. It's really easy to set up. So the first thing that we need to do, and probably the biggest difference in function here, is that instead of using a noise texture or a gradient and using a driver as the input parameter for that group mask, what we're going to do is that we're going to basically create almost the exact same system. However, the group mask element itself is going to be a constant. Let me show you specifically what I'm talking about. So inside of my brass submaterial group, I want to add in under the processing section a constant, which is nothing more than just a solid layer. Now, right now, I don't have any diffuse values associated with this material, so notice under the BRDF, the diffuse amount is set to 0, and the constant color is its effect is at diffuse color. So we're not really seeing anything right now because this element doesn't have any diffuse color values associated with it. However, if it did, this would just basically override, this color right here would override the diffuse color associated with that material, which is pretty cool. However, we're not going to use it through the lens of creating a color. We're going to use it as a group mask, and let's just change its role. over, mine's under recent because I've been doing this before, but it's also under shader control group mask. And now check it out. The color values here are replaced with a value, and a value of 100%. We're going to see the contents of the folder that the group mask element is currently residing within, and then add a value of 0%. Check it out. We're basically going to turn it off, and now we see the pewter itself, the one that's behind. So we're getting the exact same result, but now instead of having a color value that's determining the masking elements, we're getting a percentage, and we can tap into that percentage using the nodal shading system. Let me show you how it works. It's pretty neat. So once again, let's bring in this constant down into our schematic here. And there's a couple things in here that we'll need to initially flush out. So we need to tap into this value guy right here. Okay, because this is the one that we want to have influence on inside of our scene. So let's actually put this back to 100 just so we can see the final effect. Okay, so now what we're going to do is that we're going to go grab an occlusion layer. We're going to create an occlusion layer. So let's add one. So it's going to be under, let's see, I'm horrible with lists. It's under shader inputs, shader nodes, and then processing, and then occlusion. There we go. Now, because it's not inside any sort of material group over here inside the shader tree, we can reuse this element in many different locations, and I think it's pretty neat. Let me show you and continue to show you what I'm talking about. So here's the occlusion layer. Let's go ahead and change its type to concavity and convexity, and of course, we're going to take its texture value, this one, and use all of this information and plug it in over here. And you can immediately see, instantly, we're getting the exact same results as we did last week. Instead of using a very complex network and a very difficult system, we've distilled it down into something that's very, very simple. And since this occlusion layer is a node, it can be used in a number of different capacities. Let me show you an example of what I'm talking about. I think just to make life a little bit easier, let's just add in a simple cube into the mix. So it's on its own mesh item. Let me zoom out a little bit here. There we go. And right now, my cube is way down over there. Let's go into a 3D view. And I'm just going to polygonally grab that cube, push it way out over here. There we go. And let's do this. Let's incorporate this cube into the same material setup, or a very similar material setup to what we had before. So I'll go over into my schematic, and let's put the cube, I arbitrarily went a little too fast here. I want to assign the cube its own material. Call this cube. There we go. Wonderful. Now it goes black because the settings that I had before, my diffuse amount, were at 0. Let's put that to 80. There we go. Now we can see it. Wonderful, looking pretty good. And let's do this. Let's go back over into our schematic now, and let's grab this material. We'll throw it down over in here, and let's see. And I think what I'm going to want to do is, actually I changed my mind. What I'm going to do, I'm just going to redo. Basically, remove that node. I'm going to duplicate this constant, and we're going to create a very similar setup to what we had before. But since here's kind of a cool little trick, I'm not actually going to duplicate it because this is just a solid color, right? That's all it is, and we're using it as a group mask. So what I'm going to do is I'm going to make an instance of it. So we'll create an instance. Now these two are linked to each other, but I want to move the instance into the cube material group. So now that one is, this constant value is only being applied to this one over in here. It's still set to group mask. Let's put that in its own group. And we'll just make it a very kind of silly example here, just to kind of prove and illustrate that you can, in fact, recycle these elements. And let's make this diffuse color like a bright pink. There we go. And its base material inside that group, we'll make it a very bright blue. And now, if you look very carefully, since we're using pretty much the exact same setup, we're seeing the results of that occlusion group mask that we created before. It's working. So we're using one occlusion layer to feed two separate constant textures inside of our shading network. That's the cool thing about working nodally, is that we're no longer forced to work into this hierarchical layer-based, if you will, shading network. We can now work non-linearly and have single elements inside of our graph influencing a multitude of different textures downstream of it, which is very, very cool. Personally, I much prefer this system of creating the masks in comparison to what we went over last week. It's just a little bit more efficient. It's a little bit more fast, and allows us to very, very quickly understand the relationships between all the different elements that are driving the final effect inside of our moto scene. The last thing I want to show you are some new shader inputs that are built into the nodal system inside of Modo. They're pretty cool, and they allow us to create some very compelling effects. And I think I'm just going to recycle some of the assets that I have currently in front of me to illustrate this really powerful feature of the nodal shading system inside of Modo. I think what I'm going to do, let me grab my cube, and I'm actually going to make my little cube here into an ice cube, which is pretty cool. I'm going to convert this over into a vertex selection and just simply round out the corners a little bit. And I'm being a control freak, and I know I shouldn't be a control freak, but I am. It's going to happen. Let's just bevel these a little bit more, get a little bit more surface detail. Yeah, there we go. Let's do a simple little edge bevel. There we go. That's good enough. Yep. And now what I'm going to do is I'm going to place this inside of my little goblet. I'll make it a little bit smaller. There we go. And I'm going to make a little ice cube for my goblet here. And what we're going to do is that we're going to control the color of my little ice cube as it crosses over into some water that I'm going to create inside of my goblet. So let's just do that real fast. Grab some polygons here. I'm going to copy those and paste them onto a new mesh item. There we go. And I'm going to close this element up just by hitting the P key there. And then, of course, we're going to need this to be a complete volume. Let me flip the polygons so they're going in the opposite direction. There we go. And let's get my ice cube in there. There we go. There's my ice cube. I want to place my ice cube, if I'm in the right selection set, I want to place my ice cube just in the water ever so slightly like that. And let's just give it a cool little rotation angle as well. There we go. As if it's bobbing carelessly into the water. Okay, cool. That'll do. And now what we're going to want to do here, or what I want creatively, is I want to be able to control the color underneath the water a little bit more directly. And this is one of the cool things that we can do easily inside of Modo. First things first, though, let's go in and start establishing some materials. Clearly, we don't want to have gold liquid on the inside, albeit that is very, very cool. So here's what we're going to do. Let's just create a couple new materials real fast. So here's the material. This is the water. I'll name this water so it's easy to understand. And give it its own polygonal tag. We'll call this water. And we'll use a nice color of blue for the time period. And while we're thinking about it, let's just go into the Material Trans tab. Make this a little bit more transparent. Let's make it 100% transparent. There we go. Now we're starting to see all the lovely gold behind it, which is pretty cool. And now let's give it a little bit more of a refraction index. Let's do 1.3 so it matches water. And now we have to start messing around with the absorption distance. And this is where it's going to take some time. And I'm doing a very reflective material. Let's see if I can get in there and get a better understanding of how this is all looking. Yeah, let's do absorption distance. Let's do 500 millimeters. And see what we get. Let's also give it a little bit of transparent color here. Let's make it kind of a blue. There we go. Yeah, so it's kind of turning out green, but that's okay because it still gives us the illusion that we're after. Lovely. So it's maybe it's a poisonous drink inside inside of our goblet. It's something that perhaps you'd give to an enemy of some kind. But I want to be able to control the color of my cube inside the water. And this is where the nodal shading system really comes into play here and where it really shines. Let's go back into our schematic. This constant value here is responsible for driving the group. So I don't want to have any of that edge detail in there. It's just kind of generally slowing things down. But what I am going to do is start adding in some new features inside of Modo, because this constant value, let's just change its role inside of my cube. Let's just restructure things here a little bit. It's not going to be a group mask anymore. Let's just do diffuse color. We'll take it out of that group. Let's just generally do some house cleaning. We don't need the contents of this guy anymore because I just want this constant value. And it's probably best that we, instead of using an instance on this constant, let's just change it. Let's just delete it. So let's create a new one under processing, constant. There we go. It's diffuse color, so it should go black. Let's just proof of concept, make sure everything's working. Make it a nice pink. Our cube should go back to pink. Lovely. And now we can start working with it once again. Because what we want to be able to do here is that we want to be able to drive the diffuse color value of this constant nodally through a couple new textures. Because as I mentioned before, what we want to do here is control the color of the ice cube on the top versus under the water. So we can art direct it a little bit. So let's grab it. Let's bring it over here into our schematic. And we can start working with this. And there's some new elements inside of the nodal shading system in Modo that will allow us to do this. So let's go and add a couple new elements into the mix here. I think probably what we're going to want to do is add a couple new constant colors in here. So let's do shader nodes, and we'll do processing constant. And we're going to need two of these. One's going to be the top, one's going to be the bottom. Processing constant. Go. So above the water, maybe we want it to be, I don't know, a lovely shade of blue, as an ice cube would be. Awesome. And then below the water on this one, let's be creative. Let's make it a lovely, let's make it really obvious. It's in green water, so maybe purple is the color for us. Let's just experiment with that. And so before we get further. So now what we want to do is that we want to blend both of these in a very compelling way. So if we go back, so we want to combine this one and send it over into the color value right here. And luckily for us, we have that inside of our shader nodes section. And it is under, it's not under shader nodes. It is under it's under channel modifiers. I apologize. It's under color blend. Aha, check it out. There we go. So here we have color blend. And now we can take the output color of this one. There we go. And then the output color of our light blue as the input color of one. And now, check it out. So we're basically combining these two colors, and we're going to send it over here. All right, now, on the surface, you're going to say, wow, Pat, that's really, nothing's changing all that much. Why are we taking two colors, blending them in together, and sending it over here? Well, here's the cool thing about the color blend. It has a mask channel, and we're going to mask it with a new element. It's the cool shader input. So let's go add it in. So it's under shader inputs, and we're going to do this ray type. It's pretty neat. This ray type node inside of Modo allows us to basically capture a whole series of other camera rays, reflection rays, refraction rays, and use those rays compellingly inside of our shader network. Let me show you how it works. So you can already see we have camera rays, shadow rays. What we want to do is refraction rays. Since we have an absorption distance and a refractive index on our water materials, it's going to go in and understand every area that's being affected by that refraction index and capture it for us. So we're going to grab this refraction ray and we're going to use it as a mask. And let's see. Yes, look at that. Now I think I have my colors backwards here, but we're getting the result that we want. So now we're able to control the color of our cube on top versus the bottom. So on this one, this is the one that was supposed to be. We'll swap the inputs here real fast. There we go. That one, that one goes over in there, and we're getting the result that we want. Wonderful. So it's only this constant value right down here is only being applied to the areas that are getting the refraction rays inside of that material, which is very, very cool. This herein lies the power of the nodal shading system inside of Modo. We can actually capture and access a number of camera rays and refraction rays and any number of rays in this ray type shader input and use that as part of our shading network. I love being able to mask off of physical based properties and attributes inside the scene. It's very, very cool. Now there's a couple other things in here that I would absolutely encourage you guys to take a look at. We're not going to have time today to go over all of them, but if you go back into the shader input section, check it out. We were in the ray type. We can also do some ray casting, so we can fire off rays from a surface, and we can also do some illuminate, shader inputs as well. I would highly, highly encourage you to check out the inline help system inside of Modo. It's quite good, and there's some very good examples that illustrate exactly the illuminate and the focus of the ray cast nodes. I think you're going to find them pretty fantastic. This video and this tutorial was really aimed to give you a basic understanding of how the nodal shading system inside of Modo works, and I think we've done a pretty good job of outlining the basic kind of framework. Of course, if you have any questions, just let me know. I'd be more than happy to help you out. I think that you're going to find that these simple examples can and should be applied to your treasure chest, as they allow us to create a more compelling result quickly and in a more efficient, recyclable fashion. We don't want to have 2,000 separate different items inside of our shading shader tree, it begins to bog down Modo, and it's going to dominate a large percentage of our memory. So being able to use procedural textures in combination with elements that are already being calculated and captured inside the Modo rendering system, like camera rays and reflection rays, really make the rendering a little bit more efficient on the back end of the Modo universe. So let me know if you have any questions. I'm more than happy to help. Thanks, guys. See you next week.